students, welcome to online video class by Mentors Group of Institution. So in this video, we are actually giving a brief introduction about the SSC-JE exams and a small topic of a mechanical engineering which can be considered as a heart or the basic subject, which is the thermodynamics. So before starting, as you all know, the SSC-JE has actually two papers, or that is two tiers exam. In the first paper or in the first tier exam, it comprises of 200 marks, in which 50 marks is actually denoted or dedicated to the general intelligence reasoning. And another 50 marks is for general awareness, and the next 100 marks comes your professional knowledge. It can be either civil or other mechanical or electrical. So among these mechanical, there will be totally of 100 questions, and in total the paper 1 will be of 200 mark. And still the race is not over. And after that you will be awaited with another exam, that is the paper 2, which comprises of 300 marks of descriptive exam. That's what the most important one. The descriptive exams 300 marks and the first objective exams 200 marks combined together, and that will be your final score which determines your rank in the SSC-JE exams. So in this video, we are actually giving you a small topic, or we can say a small conceptual topic of the thermodynamics, and what is meant by this thermodynamics and how the thermodynamics is being applied in various applications. Are you ready? Let's start. So in a nutshell, we can say that thermodynamics is actually dealing with some sort of energies. But wait, did I say energy? Yes. More precisely, I can say this thermodynamics deals with a transmission of energy, or more precisely, a transmission of heat energy into work. So as you all know, the work or heat, whatever may be, this is actually a form of energy. The heat, as you all know, is the best example of, as we know, is an example of thermal energy. Well, I have said the another type of energy as work. What is meant by work? Work, as you all know, is the best example of a mechanical energy, because there is none other than a best example of work. So in this thermodynamics, what we are dealing, we are actually converting the available heat in my hand to the corresponding work, which is what? A mechanical energy. So we can say the heat into work, this transmission from heat to corresponding work. This is what this subject deals with. But before going, let me tell you some basics of this thermodynamics, and that's what this whole video is about. Because in any thermodynamics textbook, you can see the first term that comes into your mind or comes into your eyes is what the system is. The system, the surroundings, and the corresponding open system, closed system, isolated system. But we can define the system in a simple definition. For example, let me take a class. For example, a class of 50 students or 10 students, as you like, we don't have any problem here. Like 10 students or 20 students or 50 students, whatever maybe. And now, you have taken 2 or 3 students as per your interest. That is, if you are a teacher and now you are only gaining concentration, or now you are only looking on to 2 or 3 students among that 50 students. So now your concentration is only towards that 2 or 3 students, right? The remaining 47 or 48 students is actually, you don't care. You are just looking on to that 2 or 3 students. So that 2 or 3 students, or a corresponding area in which your observation is there, that area under observation is known as the system. So for that, let me take a simple example. For that, I have the same example of having a classroom here, in which, for example, I have a 50 students, or as you know, I can't just draw 50 people here. So let me change that 50 into a small number. For example, I have, as you can see here, 3. Now it comes 4, 5, 6, and corresponding 7 students in my class. So now I am making my concentration only to the middle bencher of the first row student. Who is it? This man. So now I am a teacher. I am actually only concentrating towards this man. So now this person is what my system is. Why? Because now you are actually concentrating this man here. The other 6 students in this class is actually none of your business. You are only concentrating on this one, right? So that area or that people in which you are observing or you are concentrating, this is what correspondingly we can say the system. But what happened to the other 6 people? Because they are also in our class, right? So the corresponding, the other people other than the system inside this class, that is the area other than the system, that is known as the corresponding, we can say, the surroundings. The word itself says surrounding. What is meant by that? The area which is actually outside towards the system. You can say here, these 1, 2, 3, 4, 5, 6. These 6 students actually comprises of the surroundings. So this is what the basic concept of system and surrounding. But wait, one more term is there. Because if you are looking towards any good textbook in thermodynamics, you can see along with the word of system, surroundings, there will be another term which is known as universe. So what is meant by this universe? Because obviously there will be questions, sir, what is meant by universe? Let me tell you. So as you can see, you have described the system and the surrounding inside world, this classroom. So this system, that is this boy, and the surrounding, the remaining 6 boys or girls, whatever may be, that all is actually comprised inside our classroom. That classroom in which the system plus surroundings, that's what we call it as on the universe. That is the total area which comprises of system and surroundings. That's what our universe is. So in this figure, which is universe, our whole classroom in which both system and surroundings is there. So this is what actually in a general concept of a system and surroundings. But wait, we are actually started with thermodynamics. Now we have ended with a simple example of a classroom. So how we can actually define the corresponding system and surroundings with the help of a thermodynamics? For that, let me take a simple example of a bottle, or we can say a corresponding, I have a pot here in which I am making tea, because we can relate the best example if a food is included with it, because the food is the best example in which we can connect with it, right? So I am saying I am making a tea in a simple pot here. So let me take that as a symbol representation, visual representation, and I can see how a system and the corresponding surrounding is and what type of systems are there, and there comes the major 3 parts of a system, that is open system, closed system and isolated system. Let me tell you what that is. So in a general case, we have discussed about the system and surroundings like a classroom. But we are discussing thermodynamics here, right? So now, let me take you a simple example of a system and surroundings along with the universe. Again, we have one more term remaining. That is what? A surprise element which is known as boundary. As the name suggests, you know what is meant by the boundary. What is meant actually boundary? It is actually a partition, right, between 2 lands, or we can say 2 houses, or even we can say in the ground. What is meant 4 or 6? It is actually the boundary between one thing and another thing. So here we are discussing the boundary with respect to system and surrounding. Let's see, come here. So as you can see here, if I am observing the space inside here, so this is what my area under the observation. So this area under my observation or area in which I am studying, that area is known as correspondingly system. So that's what I have written here, the basic definition, because you also need the notes, right? So what is meant by the system? We can say the area under the observation or study. So what is meant by the area other than the system or area outside the system, the region outside the system? And for example, in this board, I can say in this board, this region is what my area under observation, so I can say it is a system. So what is the region outside the system, the area other than the system? That is what the whole this region inside the board, that is what my corresponding surroundings. So that is what we can say, the surroundings can be defined as the region outside the system. You see the concept. The one thing is again our study and the other thing is again outside our study. So now wait, we need to define a boundary between the system and surroundings, because we don't know where is the system's that area is ending or where the surroundings area is starting. So there we have to say a partition between the system and the surrounding, and that comes or there comes our hero, which is known as the boundary. So here you can see this blue mark, in which these blue marks actually separates the systems from the surroundings or vice versa, the surroundings from the system. So this partition, as you can see here, in which the system and surrounding is being divided, this partition line is actually known as the corresponding boundary. The word itself says it. The name itself, you can suggest it. It actually boundary or corresponding partitions the system and surroundings. So that's it. So wait, we have one more term remaining, right? What is that? Universe. Let's see what's meant by universe. So firstly I have said system plus surroundings is equal to universe. You just don't need to by heart. We just need the concept, because that's what the corresponding mechanical or all the subject, it's not about the mechanical, it may be civil, electrical, electronics, what it may be, you just try to grasp the concept. That's what the learning is all about. So let me tell you what is meant by the universe. So here there is a system, here there is a surroundings. Where is this system and the surroundings? This is actually inside or on this board, right? So this total board in which my system and the surroundings along with the boundary is laid. Or let me tell you in another concept. If my system is here, my corresponding surrounding is actually, as you can see, which is inside this box. So now I am actually confining my surroundings from this whole board's area into inside this box. Fine with that? Okay, so now this is what my system. This region other than the system, that is inside the box, you should note it, inside the box, that is what my corresponding surroundings. So this system, this boundary and this surrounding, that is the box in which I have drawn, this is what correspondingly we say the universe. So this is what universe is. That is system plus surroundings along with the boundary line, that all comprises of a universal thing. That is what our universe is. That's what the universe is, a simple definition. That is, the whole thing is actually inside the universe. So this is what the basic concept of system, boundary, surrounding along with the universe. But still we have one more thing remaining. Firstly, I have said we have to now define about the system and its types. So let's see what is the corresponding system and how the system can be classified with an example of a simple teapot. And now I am making a tea for you. Let me tell you and let me explain you with along making the tea of what happens to the corresponding three type of system along with the transfer of mass and energy. With a simple example, let me tell you that. So we have discussed about the system, boundary, surroundings, universe. Now comes a real life example. So for that, after this class, now I am taking a teapot in which now I am having a tea. So now the tea is not ready. As you all know, I have poured some water inside this teapot and I have put some tea powder and I am giving a heat outside it, whether it be a wood or corresponding a gas, as you like, because that's not our observation here. So now my area under the observation is actually this teapot. It's not about the handle, you know, it's about the water inside the teapot. So I can say this is what my corresponding word area under the observation, that is my teapot. So I can say what is the system here? The teapot. Why? Because that teapot is what I am studying. So I can say this teapot is what my system is. So the area other than the teapot, that is the corresponding from here to all these things, that is the atmosphere around the teapot, that will be what? My surroundings. So now we are looking on to two important transfers here. That is from the surroundings, that is the surrounding here, that is, as you all know, the area or the region that is outside the system. I am actually supplying a heat, right? That is what basically we say burning is. It's either by a gas or it's either by a wood, that doesn't matter. We are actually supplying a heat from the surroundings, right? Yes, to where? To the system. So there is a transfer of what? Heat is there. A heat transfer is there, right? Yes, where? From the surroundings to the system. Actually, I am taking it in the conceptual level, that is in the basic level, so that you all can understand. So from the surroundings, I am providing a heat towards the system. So I can say, according to this concept, there is actually a heat transfer is there. Wait. What is meant by this transfer? Because we are not dealing with the heat here. We are dealing with the traveling of the heat. That is either from the surroundings to the system or from the system to the surrounding. That travel of the heat, that is that transfer of the heat from system to surroundings or vice versa, that is what we are knowing as the heat transfer. So we are not dealing with the heat here. We are dealing with the heat transfer. So obvious from this figure or from this experiment of simply making tea, it's obvious that we are transferring heat from the surrounding system. So now here comes the most important one. So now there is a heat transfer. So after providing a heat for some time, what happens inside the water, in which eventually it will become a tea? Whenever I have poured some water and after that I have actually inserted some tea powder, it's fine. So after heating this corresponding teapot for a long time, it's obvious that the water inside this corresponding teapot will, what happens? Vaporizes. So now there is again a transfer is there. What transfer is here? Because whenever I am giving a heat for this heat pot, after a certain time, the mass of this corresponding water inside the teapot actually decreases. Why? Because it will be reducing due to corresponding reduction by the water vapor. This water now will convert into the water vapor, and as a result, the mass of the water decreases inside the teapot. So here, we are not actually dealing with the increase or decrease, we are actually dealing with the transfer. Firstly, there is actually heat is supplied towards the system. Second case, that is from the teapot towards our surroundings. That's what in the form of water vapor. The water is actually escaping from our system. That is a transfer of mass is there towards the surroundings in the form of what? Water vapor. So I can say due to this escaping of the water vapor, that is the water vapor molecules, there is a transfer of what here? Mass is here. that is water is actually escaping. So I can say in this case, along with the heat transfer, there is a corresponding mass transfer is there. But look on to this concept. Here the heat transfer is from where to where? Surroundings to system. But the mass transfer is from, yes, very good, from system to the corresponding surroundings. So this type of system in which there is a heat transfer and there is along with it there is a mass transfer just like this, that is what we call it as on the most famous and the first type of system, that is the corresponding open system is. That's it. So now this is what an open system, that is there is a mass transfer and that is a heat transfer. And one more point is there, it need not to be necessarily from surroundings to the corresponding system or from system to surroundings. In this example, the corresponding surroundings to system, it was the heat transfer, and from system to surrounding it was mass transfer. It can be vice versa depending upon your factors and depending upon your experiment. It may be a coffee, tea or whatever, juice, water maybe is there. It's not what our observation is. We are just looking on to whether there is a transfer of mass or energy is. It can be from system to surrounding or from surrounding to system. And that transfer is with, along with there is a transfer of mass and heat is there. That is, there is a both heat transfer and a mass transfer. That type of system is known as open system. So well, wait, we have two more systems remaining. Let me tell you in another simple example of a corresponding same concept, but now I am taking a lid and now I am covering the corresponding top portion of this teapot with a tight lid such that the water vapor doesn't escape from our teapot to the surroundings. Let me do that. So now let's take the second case. I will not say the name because you know the corresponding name, that is the closed system, second type of system. So what happens here? So what we have actually ended with that, we are now covering the top of the teapot with a corresponding lid such that now no water vapor escapes through here, but still I am giving a heat from the surroundings to the corresponding teapot, which is what my system is. What happens here? Is there a heat transfer here? Yes, there is a heat transfer, sir. Where? From the surroundings to the system. So I can say there is a heat transfer. Yes, but can you say whether there is a mass transfer here? No. Why? Because in the initial case, we do have a mass transfer of water from the system to the corresponding surroundings in the form of water vapor. But now I have closed the top of the teapot such that no water vapor leaves from the system to the surroundings. Why? Because I have covered. So the most important point here is we are assuming that there is not even a single drop of water vapor is being escaped through this lid. That is, this lid is strong, leak proof, or I can say it is strong and such that no water vapor can be correspondingly escaped from here. When a water vapor comes here, stop it, you can't go there. That's what the corresponding lid does. So I can say now no water vapor actually escapes here. So whether there is a mass transfer or not, no, there is not a single water vapor is escaping. So I can say no mass transfer is there. But still I can say there is a heat transfer. So heat transfer is there but no mass transfer is there. This type of system in which there is still a heat transfer but there is not a single mass transfer or a single water vapor escapes, that type of system is known as the correspondingly our second type of system, which is the closed system. So in a conceptual point of view, we can say whether the mass and heat is transferred, it is open system. When the mass is actually closed, that is the mass transfer is closed, but still there is a heat transfer, then what happened? That corresponding system becomes closed system. So this is what I can say the most two important type of system in the thermodynamics. So probably now you may be clear with the corresponding system and surroundings, and please note that I am taking this class in the type of a basic level. Probably you all know what these kinds of system and surroundings is, because we need these kinds of concept in a ground level. That's what we have been explaining in a detailed manner. Fine with that? Don't misinterpret me. Okay, fine. So now second type of system is over. Now comes the last, final and the most important one. That is what? The isolated system. So for the isolated system, let me continue or resume my story. So now my water inside this teapot is actually boiled, and now I am pouring, or I am putting some tea powder inside it, and some sugar inside it, and now I have to transport this tea from my home to my office, that is where my class is being taken. So now what I will do, I will just take a thermo flask or a thermos flask in which I will pour that tea or coffee or boost or water maybe into that thermal flask, and I will carry from my home to the office. So what happens that tea or coffee inside the thermal flask? Whether the heat of that tea or coffee loses when I reach from home to my corresponding office? Never, never, never. That is, the heat doesn't get lost for say, just say for like 5 or 6 hours, and also obvious there will be no loss of mass, because initially how much amount of tea was there inside the flask, the same amount of tea will be there whenever I reach the office. So I can say there is no mass transfer because no amount of tea is lost, and obvious there is no heat transfer. Why? Because the heat of the corresponding or the temperature of that tea will be approximately, not it approximately, because we are assuming it, approximately will be equal to the temperature of the tea whenever I reach the office. That is, the temperature will be same. What happens if the temperature will be same? Assumption. There will be no heat transfer. Why? Because if there would be a heat transfer, then the temperature of that tea would be becoming decreasing. Or we can say that tea will be becoming cold tea, right? Not that cold tea, a corresponding tea which has become cold. So still that tea is hot. So I can say there is no heat transfer and there is no mass transfer whenever that tea is being correspondingly poured inside a thermos flask. That type of system in which there is no mass transfer and there is no heat transfer, that type of system is you know the name. That is what? Isolated system. The word itself says that is, the system is completely isolated from the surroundings such that there is no heat is transferred from the system to the surroundings or vice versa, and there is no mass is transferred from the system to the surroundings or vice versa. That is, the system is completely isolated from the surroundings, right? That type of system, there is no mass transfer and no heat transfer. That type of system is known as our third type of system, which is isolated system. So let me tell you the definition of an isolated system, and let's conclude this basic conceptual thermodynamics demo class. So we can say an isolated system in which there will be no heat transfer and no mass transfer. It is completely isolated. So this is what the 3 types of system based on whether there is a mass transfer or not and whether there is a heat transfer or not. So this is what the basic concepts of the thermodynamics, and also please note there are more other concepts to come. We are just showing some basic thing in which you can understand simply, and this is what the whole subject is all about. That is basically this thermodynamics is a simple subject. We are overthinking it and making it as a complex one. So this is what the whole thing about thermodynamics and about the system. So we, the Mendes Group of Institution, wishing you all the best for the upcoming SSC-JE exams. Thank you.